Welcome to Electronic Seed YouTube channel. Today in this video, we will learn about analog and discrete time signals. Let's get started. We will start with two foundational signal concepts, analog signals and discrete time signals. Think of practical examples like temperature over a month, voltage ranges, or the difference between analog and digital clocks. Before we get into formal definitions, let's consider a clock example. An analog clock has continuous hands that can point to any time value, like exactly 11:30. A digital clock, on the other hand, jumps in discrete steps like 12, 13, 14, and cannot show intermediate states like 12:30. This distinction between continuous versus discrete possible values is the key difference between analog and digital signals. An analog signal can take any value within a given range, with no gaps or forced steps. For example, temperature might range from a max of 47 degrees C down to near 0 degrees C values, like 27.8 or even 27.818 degrees are perfectly valid. Similarly, a voltage analog signal from 0 to 20 volts allows any value, such as 5.3 volts, 12.78 volts, or 19.999 volts. The core idea is a continuous range. A discrete time signal concerns timing, not the range of values. The definition is, a discrete time signal is a signal defined only at discrete time intervals. For instance, if you record the temperature only at 11 a.m. each day, you have no data between those samples. The underlying physical signal, like continuous temperature, remains analog. All real-world physical signals are fundamentally analog. A discrete time signal is simply a subset of an analog signal, taking values only at selected instants. Visually, imagine a smooth analog curve, and then keep only the samples taken at 11 a.m. each day. In electrical engineering, a signal is often a change in current or voltage over time. For example, V of t equals 5 sine of t volts, which varies continuously from -5 to +5. Sampling that signal every millisecond gives you a discrete time signal, which is essentially a list of numbers. But remember, discrete time is not the same as discrete amplitude. Only the time is discretized here, the amplitude remains continuous.